and welcome. My name is Father Chris Martin. I'm the Vice Rector in charge of Cardinal-Glennon College Seminary. On behalf of Archbishop Carlson and Father Mason, the President Rector, we welcome you all to the 5th annual Cardinal-Glennon Lecture. A little bit of brief history again about this institution, specifically the college, that John Joseph Glennon was the 5th Archbishop of St. Louis. He was made the Archbishop in 1903 and served until 1946. He was known as the Great Builder of St. Louis. During his tenure, he had great programs that welcomed many immigrant populations to the Archdiocese of St. Louis, helped him establish their communities and parishes. He began the construction of the new cathedral, and it just so happens that he also built the building that you're sitting in right now. And so we give homage to Cardinal Glennon and have named the college seminary after him. Tonight's lecture is a complement to the Kenrick lecture that is hosted by the School of Theology each year. And again, this is the 5th annual philosophical lecture that we've had. Tonight's speaker, we are very blessed to have with us Father Spitzer. Father Spitzer, a brief rundown of his curriculum vitae, was born and went to high school actually in Hawaii, which isn't a bad thing at all. He got his bachelor's degree from Gonzaga University, his master's from St. Louis University, his master's in divinity from the Gregorian University in Rome, his theological master's from Cambridge, and his PhD from the Catholic University of America. Amongst many of the things that he has done and accomplished in his life, he has been the president of Gonzaga University, and he currently appears weekly on EWTN's Father Spitzer's Universe. He is the author of 8 books, has 3 currently in publication. In particular, he's going to speak, I think, about one that'll be coming out very soon about suffering. Father Spitzer is a priest of the Jesuit order, and he's currently the president of the Magis Center and the Spitzer Center, which are both catechetical sources where he is creating curricula for middle school, high school, college, parish, and adult education. He is the author, or one of the co-authors of, he said today, a 1,500-page compendium of Catholicism, and also a 150-page shorter version, which is probably the one that all of us will use more often than not. So it is my extreme pleasure to introduce tonight's guest lecturer, Father Robert Spitzer.
Thank you very much.
Yep. And then your water, your cup of water is over here on this other side
Perfect.
table. Okay.
Thank you. Well, it's an honor to be with all of you tonight, and I'm just going to maybe start with one thought, just in case I start perhaps getting over your heads, and I won't get over many of your heads, but if I do, inadvertently, there is a place where you can get a much longer and kind of more detailed, slower version of what I'm about to say in about a little over an hour here before the Q&A. There are all kinds of free videos on the site, free articles that go through the faith and science material very, very thoroughly. It's called magiscenter.com, M-A-G-I-S center.com. And I'll refer to it throughout the evening because we have a whole variety of things there. If you know young people, too, who are just teetering on the brink of just not being able to reconcile faith with science, I'm begging you, send them to this site or send them to our Facebook. It's also, of course, Magis Center Facebook account, where we really do talk about these issues, post on them, talk about everything, honestly, from aliens to Galileo to exoplanets to and what we're going to be talking about tonight, evidence for God from contemporary physics and a variety of other things. So if you wouldn't mind promoting that site or going to it yourself, if I just sort of move too fast, let me know. There's a popular cultural myth out there, which is affecting a good number of our young people, which says that faith and science are contradictory. In fact, the myth has been so successfully propagated and promulgated, I should even say, by specific groups of people that 39% of our young people today, moving up from 24% to 39%, have moved out of all religion altogether. They've become nuns, N-O-N-E-S. No confusion with the N-U-Ns. But but the key thing is this group of individuals has gone up about 1.5% per year, and 49% of them say one thing. The major reason that they left the faith, this is a Pew survey from just 6 months ago, the major reason that they left the faith is that science and reason have thrown religion out the window. It's so patently false, it's so absolutely wrong, yet at the same time they're utterly convinced of it. And here's why they're wrong. Here's why we need to get the word out to them, and we need to kind of nip this kind of stuff in the bud. One allegation is that the Catholic Church, since the time of Galileo, has been anti-science, and that simply is not the case. And I just wanted to give you an idea. By the way, if you go to the wiki site and you put priests, science in there, you will see 30 other priests who are leaders in developing the natural sciences that I'm not going to talk about here. I'm just going to talk about 4, which every person should be aware of. Nicholas Copernicus was not a priest, but he was a Catholic cleric, and he certainly was also a canon lawyer, along with being a cleric in the Catholic Church. We all know him as the first person to mathematically postulate the heliocentric universe, the solar system with the sun in the center and the planets orbiting around, including the planet Earth. So we know Galileo was not exiled because he was preaching heliocentrism. Let's face it, heliocentrism was brought in by a Catholic cleric. Number 2, Gregor Mendel. I think everybody recognizes him as the father of quantitative genetics. And of course, he was not only an Augustinian monk, he was an Augustinian abbot. Of course, maybe some of you don't know Bishop Nicholas Steno, but Bishop Steno was the father of modern geology and was the discoverer of stratigraphy, right? Go down these various fossil layers and so forth, and you are not only able to date certain things, but you can actually know what things were like and how to assess them and analyze them. That was a Catholic bishop in Denmark. And of course, the most famous, the one we'll talk about tonight, Father Georges Lemaitre, later Monsignor Georges Lemaitre from Belgium, who basically got his PhD from MIT, became a colleague of Albert Einstein's and Hubble's, and you can see his picture there with Albert Einstein. That's the priest, and also with Edwin Hubble there at Mount Wilson Observatory. It was Georges Lemaitre who discovered the Big Bang Theory. In 1927, Lemaitre published it for the first time, and basically by postulating an expanding universe, he was able to solve a big problem called the recessional velocities of extragalactic nebulae. Don't worry about the problem. The main thing is he solved it, and he solved it creatively because the general theory of relativity by itself, Einstein's great masterpiece, was not able to do so. And he said that the solution to why the further away you get from a galaxy, the greater its recessional velocity, it should run proportionately if the universe as a whole is expanding. And what he meant to say was, that if the space between the galaxies is stretching and growing, so there's more space, the universe is getting bigger and bigger, but the galaxies are not moving away from each other in fixed space, the space between them is actually stretching and growing like a balloon, right? You put some dots on a balloon and you blow up the balloon, and the elastic on the balloon is like space. The space is stretching and growing between them. That's how you explain it. And actually, he put together a series of equations, the Lemaitre equations, with the Lemaitre constant. It's now called the Hubble constant today because, of course, Edwin Hubble revised the constant so that it's a little more accurate according to the observational the astronomical observations he'd made since that time. But this, when Lemaitre presented this to Einstein, Einstein said, well, the mathematics are perfect, but the physics is preposterous. Imagine an expanding universe. What a funny concept. But of course, we all know today that funny concept has been rigorously verified, and not only rigorously verified, but Einstein came to believe it. He went up, Edwin Hubble showed him in 1931, invited him up to Mount Wilson and said, you got to look at this. I think the universe is expanding as a whole, and I got the proof in the redshifts. And Einstein and Lemaitre are there in this, Einstein and Hubble are there in that picture at Mount Wilson. But later he went back to Lemaitre and he said, this indeed is one of the most fascinating theories or explanations of creation that I have ever heard. So the Catholic Church is not against science. I mean, there's a Pontifical Academy of Sciences, right? The Jesuits are running these observatories all over the place in the world. I mean, this is ridiculous. There's always been a natural, proclivity, faith and reason coming together, science and faith coming together throughout the Catholic Church. And as I said, just go to that wiki, Priests and Science. It'll absolutely shock you. We're not talking about Nobel Prize winners who belong to the Catholic Pontifical Academy of Sciences. We're talking about priests. So it's an interesting thing. Yes, the church has very much been ingredient to that. And we have been unfairly caricatured. We have. And, history proves it. Just saying. Let's get to another objection that has been forwarded. And the objection that's been forwarded is that there is no evidence for, a creation, evidence for an intelligent creator that can come from physics. And in a minute, we're going to talk about the horizons and limits of scientific method. But before we get there, I just want to give you a quick sense of the universe, what we think about it today, and some hypotheses about maybe another kind of pre-universal or extra-universal state that might exist, things like multiverses, just to give you the lay of the land, because as we kind of get into the evidence, we have to cover those pre-universal and extra-universal theories, right, because these theories, they're possible. And if we don't respond to a plausible or possible, it's not necessarily a plausible hypothesis. We don't have any evidence for any of these theories of an extra-universal, a physical reality like a multiverse or a universe in the higher dimensional space or string theory. We don't have any evidence for it, but it is a possibility, and so we need to deal with it, redress it, and then look at the evidence soberly to see if theists and Christians can have reasonable and responsible belief that the theistic viewpoint is just as reasonable and responsible, if not more reasonable and responsible than even any form of naturalism extant today. We're not talking about a metaphysical argument for God's existence, by the way, and many of them are valid. If you want 3 very valid new contemporary metaphysical arguments for God's existence, you could go to a website called magicenter.com, and you would see them right on the Faith and Science page. It's called Faith, Reason, and Science page right there. But what do we know about the universe today? We know the following things. Number one, since our Big Bang, the universe has been expanding for 13.8 billion years, plus or minus 100 million years. And that's very rigorously established, not just by Hubble's redshifts, not just by Penzias and Wilson's discovery of the 2.7 degree Kelvin uniformly distributed radiation, which pretty much could have only occurred at an initial expansion at a near singularity. That's the only way you're going to get a uniformly distributed radiation that has been decreasing uniformly throughout the entire universe throughout 13.8 billion years. So for all intents and purposes, we're pretty sure of that. But now we've got all kinds of additional evidence for the Big Bang Theory, and of course the WMAP satellite, the Wilkinson MAP satellite. We've got the 2 COBE satellites, Cosmic Background Explorer satellites. We've also got the the new Planck satellite. I mean, there's just no question. Is the universe 13.8 billion years old? I think you can almost hang your hat on it because we've got about 20 or more convergent mathematical points from different theoretical bases that all point to the same conclusion. It's pretty much it. I mean, this is an established fact. What do we know about the universe's constitution? Very, very quickly, we think about 5% of our universe is visible matter. So that would be matter that does something like the lights in the room. There's electromagnetic force in visible matter. There's also a strong nuclear force in visible matter. That's the kind that permits nuclear bonding to take place, nuclear fusion to take place, which of course gives rise to the energy of the sun and a variety of other kinds of energy sources, including atomic bombs and so forth and so on, fusion reactors and fission reactors, et cetera. Well, there's soon to be fusion reactors. The key thing, of course, is that that's about 5% of our universe. We think 25% of our universe is dark matter. That would be, remember, matter is something which causes a collapse of the space-time curvature. So, if you want the radius of space-time curvature to collapse, right, to get smaller and smaller, you want matter. And of course, dark matter has that characteristic in common with visible matter. It causes a force of attraction within the space-time field. It forces a close curvature of the space-time geometry in the space-time field. Remember, space-time in the general theory of relativity is malleable. You can actually collapse the spatial field right around a high density mass and so forth. So, but dark matter doesn't do anything else, really. It just keeps our galaxies from flying apart. That's very important. We don't want the galaxies to be flying apart at the same rate the space between the galaxies is flying apart, because then we would be dead, and that's not good. But we have 70% dark energy, and the 70% dark energy, again, very, very clearly, it does the opposite, right? Dark energy is not like dark matter. Dark energy is almost, you can view it almost like a kind of a field that connects itself to the space-time field, and it causes the universe to accelerate in its expansion. So it has the opposite effect. It causes like repulsion instead of attraction in the space-time field, and 70% of the universe we think today is dark energy. Now, if that is correct, I got news for everybody. The universe is not going to collapse. No big crunch. We're going to keep on going and going and going and going until, about 3 trillion years from now, probably. We'll reach pretty close to thermodynamic equilibrium. And about 300 million years from now, all the stars are going to burn out anyway. So we're dead-o, either from what's called heat death or cold death. Take your pick. Cold death will come before the heat death, but we're not going to collapse. The idea of the bouncing universe is very much threatened by this proposal, because if the dark energy was there in any previous phase, then the universe couldn't have collapsed. The cosmic, what we might call the cosmic constant, is positive, and the universe is likely to expand forever. Now, that's basically what we think. So about 5% visible matter, 25% dark matter, and the rest, 70%, is dark energy. What do we think about visible matter? There's about 10 to the 55 kilograms of it. That's about 10 to the 80th baryons worth of dark energy. And so, of visible matter. And so 10 to the 80th baryons, that's a lot of baryons. A baryon is like a heavy particle, a proton, a neutron. And 10 to the 80th, that's a good number. 10 to the 55th, that's a lot of weight, but very finite. Very, very finite indeed. Okay, that's the visible universe as we know it. There's a lot of nuance to that. There's 4 forces in there: strong nuclear force, electromagnetic force, gravitational force, and weak force, and a variety of other things. But you got the overlay. And now we can get to the fancier things. If the Big Bang Theory is true, and this universe is all that there is, then 13 billion years ago, the universe had a beginning. I can't tell you what a difference that was from the previous Newtonian conception of the universe. Enough said. I mean, Newton thought the universe was infinite in extent, infinite in mass, and infinite in time. If this universe is all that there is, the universe is 13.8 billion years old, and you're going to have to start facing a beginning. And a beginning, as we'll see in a moment, really implies a creator in physics. Hold on to that for about 15 minutes. The main thing right now, though, is you can pretty much see if you're good, you've got to get out of a beginning, and the only way you can do that is to posit an extra universal physical reality, so something beyond our universe, which is physical reality. And there are two major contenders for this, and that's called the multiverse, and I'll explain in a moment, and a string universe, a higher dimensional space string universe. And that's a second major contender for an extra universal proposition. So physical reality is hypothesized to extend beyond our universe. String theory and inflationary theory give some warrant to these hypotheses. And so we want to really take a close look at them and see whether those structures in turn need a beginning. And as we'll see in a moment, they do need a beginning, just like our universe. Yiko. But hold on. We've got the other thought, too, is that maybe there is some pre-universal condition of our universe. And there's two main contenders for that. The first one is the oscillating universe. And by the way, nobody believes that anymore. I don't know one reputable physicist, including Sean Carroll, who's a devoted atheist, who believes in the bouncing universe, right? Expanding, then contracting, then expanding, then contracting, because as many of you know, and when we get to the Penrose number, you'd have to get a higher, the entropy of our universe is 10 raised to the 10 raised to the 123 to 1 against, I'll explain it. But as you keep going back in each bounce, the odds against the universe having that higher degree of entropy gets higher and higher and higher until absolutely you're going to have infinite fine-tuning in order to have an infinite number of oscillations, which nobody really believes. And plus dark energy has just really done a number on the oscillating universe theory. 70% dark energy. Nobody really believes in the bounce anymore from that. And then, of course, there's a brand new theory just put out by Thomas Banks and Willie Fischler called the black crunch instead of the big crunch. Remember, when the universe collapses in a crunch in the oscillating universe, right? It's going to have a collapsing stage. But as Banks and Fischler show, you're going to get into a chaotic condition as you approach the singularity and the collapse. And when you get into that chaotic condition, it's going to literally start enervating the whole universe. It's going to start creating a condition of exceedingly high entropy. So as the universe just begins to reach the point of singularity and the collapse, the universe burns out. It goes into what's called maximum entropy, which means it can't do anything anymore after that. So what's the universe, what difference is it going to make if it re-expands? It's unable to do anything at all. It's a big, dead universe. But that's not our universe, so I don't think there's a bounce. But that used to be a favorite, but fallen way out of favor. 3 reasons, right? The amount of dark energy we have, the infinite fine-tuning, and now the dark crunch, the black crunch, which of course is death and doom for any universe. So that leaves one last thing, which a condition that's called a cosmic, essentially a perfectly stable condition of the universe for an infinite amount of time that one day explodes in the Big Bang. And we're going to talk about that possibility, that hypothesis in a moment. But we're going to save it till after we talk about some evidence. But what's a multiverse? Multiverse is one of those extra universal condition hypotheses. There's no evidence yet, but let's suppose there was a multiverse. It would be like a mega universe that is spewing out little bubble universes all the time, and each little bubble universe is self-contained and has its own point of origination. All the bubble universes do have a beginning, but there's trillions upon trillions upon trillions of these bubble universes and the hypothesis of which our universe is but one bubble universe amidst many. So that is a conjecture that's going on right now. As we'll see in just a moment, that will also require a beginning. And then there's another universe, the higher dimensional string theory universe. Here is where you get, a variety of different hypotheses, like two three-dimensional membranes, and sandwiched between them is a four-dimensional bulk space-time, and the three-dimensional membranes are colliding in the four-dimensional bulk space-time, and they're burping out additional universes all the time. And of course, this would explain, again, multiple universes, some reality outside of our universe. But as we'll see in just a moment, that too requires a beginning. So what we're going to find in just one moment when we put the evidence that we have here together is we're going to find there's a great deal of evidence for a beginning of physical reality. Whether you consider our universe all that there is, and a lot of physicists do, whether you consider that there is a multiverse, this mega universe, burping out all these bubble universes, of which in which our universe is but one, or a higher dimensional space universe and string theory, they're all going to require a beginning. So why so? How do we establish this? There are really three, if you look at this upside down triangle here, there's really three methods by which this can be done. The first is called a space-time geometry proof. Space-time geometry proofs have a very long history. Essentially, you can show that if certain conditions of space and time are met, it will require a beginning of the universe. The first such proofs were called singularity theorems or singularity proofs. A theorem, remember, is like a proof, right? Remember geometry, the theorems are the proofs, right? But then you also have the theories. And a theory is not a theorem, right? A theory is when a human being takes a look at all of the various data of physics and puts together one consistent scientific scenario that can mathematically and naturalistically explain all of the data. That's a theory. But of course, theories are not true by intrinsic contradiction. They're not true by proof. They're true for the time being, so long as you don't change the data set. So hold on to that for just a moment. But I think you get the lay of the land here, right? You basically have, some hypotheses that have been conjectured, extra-universal and pre-universal. Just before I can go there, if I can just step back for a second, go back to that, PowerPoint there, the slide, that talks about what can science do and what can't it do. Really, really quickly, what can't science do? Science can't disprove God. That's impossible methodologically in science. Why is that? Because science must take its evidence from observation. Number one, science must get observational data. Number two, all observational data must come from within the universe. That is to say, all observational data must be within the event horizon within our universe. So we can't get any observational data outside our universe. We can't even get observational data beyond the event horizon in our universe. So we know that there are certain areas of the universe that are beyond our event horizon, right? We conjecture that they're there, but we can't see them or have observational contact with them. What's the conclusion, obviously, from this? Well, if God is outside of the universe, that's the definition of God. He's beyond the universe. He's not limited to it or limited by it. If God is beyond the universe, how can you take evidence which must come from within the universe to disprove a deity which is beyond the universe by definition? You can't. Any more than a bunch of cartoon characters can assemble all the data from within the cartoon to disprove the cartoonist. It's not possible. Anybody who says it is possible is selling you something, and it isn't religion. For all intents and purposes, this is a big myth. Number two, there's another big myth out there that basically says that now physics knows everything about the universe sufficient to show that the universe doesn't need a creator. When I was debating Stephen Hawking a while back on the Larry King show, along with his co-author Leonard Mladenov and Deepak Chopra, one of the big bones of contention that came up was that Stephen was contending that science now knows that string theory is correct, and that what's called M theory, 11-dimensional Weyl-Calabi, configuration, can explain everything about the universe, and so we now know that the universe does not need a creation. There's only three things that are wrong with that assumption. The first thing that's wrong with this assumption is we don't have a scintilla of evidence for string theory. That's a problem. In fact, my friends who are stringers are worried because, of course, they know, if they don't get some evidence soon, it may fall into disrepute as a theory. So you've got to get some evidence at some point. We don't have it yet. But that's just the tip of the iceberg. The second problem is science can't ever know whether it knows everything about the universe, because science is based on theories. And the problem with theories is they're always subject to change. Why are they subject to change? Because all scientific data must be observational. And of course, if you don't know whether you've made all the observations, if you don't know whether there's something out there that you haven't observed, and believe me, science is replete with all kinds of people who thought the Newtonian universe was a veritable certainty until the Michaels and Morley experiments came and blew up the whole thing. For all intents and purposes, scientists must remain open to new discoveries that come from new and unknown observations. They must, because scientists don't know what they don't know until they have discovered it. Repeat, scientists don't know what they don't know until they have discovered it in an observation that they had not formally made or tested. And then when they do, they have to do what? Change the theory. So the idea that we know everything about the universe in its current state, where have you heard that before? And every single one of those great, almost egotistical conjectures have just been blown up within a decade. So let's forget that, and let's say very nicely that, Stephen, that was a nice thought, but it simply does not work. It does not work methodologically according to science's own prescriptions for its method. It doesn't work because there isn't currently any scientific evidence, and for all intents and purposes, we'll never know whether we have a complete data set for the universe. God has more surprises than we can possibly think of. What's my point? All that science can do is give evidence that there's something in the universe that requires its temporal boundary to be finite. That science can do. Science can give evidence from inside the universe that a temporal boundary must be finite. And if it gives evidence that there must be a finite temporal boundary, and you can do this by space-time geometry proofs, you can also do this by entropy, right? If you can do that, then you can actually show that the universe needs a beginning. And as we shall see in a moment, if you talk about a beginning, then you're talking about a trans-temporal cause outside of the universe. You're talking about a trans-physical cause outside of the universe. Let's get to the evidence. Are you guys lost completely now, or you hanging tough? Hanging in? Okay. Let's go to this upside-down triangle for a moment. We've got two kinds of evidence for a beginning of physical reality, and I'm not calling it the beginning of the universe intentionally. I'm calling it the beginning of physical reality because I'm including in this multiverses, string universes in the higher dimensional space of string theory, bouncing universes, though nobody believes them anymore, etc. So any kind of extra-universal or pre-universal theory is also included in this evidence for beginning from both space-time geometry proofs and entropy. Let's just go really quickly to space-time geometry proofs. As I said, it began with the singularity theorems a while back, but then when the multiverse stuff came out and the inflationary universe stuff came out, and a variety of other possibilities like string universes came out, basically, the singularity theorems they only apply really to our universe. So they kind of lost relevance with all these extra universal scenarios that were out there. So, we had to come up with a new set of space-time geometry proofs. And that new set, which accounted for string theory, inflationary theory, and extra universal hypotheses, the first one that was done was in 1993. That was the Borda-Vilenkin proof. Arvind Borda was a physicist over at the University of California, Santa Barbara at the Kavli Institute there, just north of me. And Alexander Vilenkin is the director of the Institute of Cosmology at Tufts University in Boston. They were the ones that came up with the first proof, space-time geometry proof, a theorem that shows that not only must our universe have a beginning, but any universe that met 4 different conditions would have to have a beginning. And this, the 4 conditions, there's one condition, sort of a weak energy condition, condition that you could, in a trillion chance, you could have a violation of that condition. And so that 1993 proof kind of fell out of favor for a while. It's still got a great deal of validity. At one point, actually, Alan Guth said, I consider, the likelihood of a weak energy condition violation of the 1993 proof to be so remote as to be unimportant. So he basically, indicated that he really did think it still had validity today. But now in 2003, all 3 of those physicists came together. So Alexander Vilenkin there at Tufts University, Arvind Borda at University of California, Santa Barbara, and now Alan Guth, MIT, right? And the father of inflationary theory will probably get, his Nobel Prize for the postulation of inflationary theory. And all these guys are very well-positioned physicists, right, in the physics community. Anyway, they got together in 2003 and wrote up a proof called the Borda-Vilenkin and Guth proof, of course, or theorem, which is now abbreviated as the BVG theorem, the Borda-Vilenkin-Guth theorem. So it has, I have the 6 steps here. In the questions, in the Q&A, if you want to know the 6 steps of the Borda-Vilenkin and Guth proof, it'll take me about 10 minutes, but I can get through them el rapido, and you can get a sense of how elegant, how simply applicable this proof is. But for the time being, if you permit me, just because of the shortage of time, I just want to say 3 things about this proof. Number 1, it doesn't have 4 conditions like the 1993 proof. It has only 1 condition. All you need to prove a beginning of a universe, a multiverse, a higher dimensional space universe, is to show that the average rate of expansion, that's called the Hubble expansion, all you have to prove is that the average Hubble expansion, the average rate of expansion of the universe or multiverse as a whole is greater than 0, no matter how small. Just has to have a teeny increased rate of expansion as a whole, and you're going to have a beginning. There's no escaping it. Absolutely no escaping it. It's a very beautiful proof. It doesn't have a lot of backflips, doesn't have a lot of assumptions. And like I said, in the Q&A, if you're interested, I'll do it real quick because the 6 steps are pretty easy. Now, why is that so important, this one single condition alone? Well, number 1, it's really hard to disprove a theorem that has only 1 condition. Much easier to disprove a theorem that has 4 conditions. But 1, ooh-wee, that's hard. The second thing is the condition is vastly applicable. So it applies to multiverses. Why do we know that every multiverse must have an average rate of expansion greater than 0? Because every multiverse must be inflationary. Every multiverse must be inflationary. You can't have a multiverse without an inflating condition. But wait a minute. If you have an inflating condition, by definition, it's expanding at a rate greater than 0, which according to BVG means definitively it must have a beginning. Absolutely. How about higher dimensional space universes and in the higher dimensional space of string theory? All such universes are nucleating universes, which means that they are in an expanding condition. And so they too, according to BVG, must have a beginning. All bouncing universes, and here's another reason why the bouncing universe died a very instant death, was because an expanding universe is always going to start with an expansion, and no matter what the contraction is, it's always going to have an average expansion rate greater than 0, which means that it must have a beginning. So you're literally dealing here. This is a proof which is vastly, vastly applicable to every known postulated extra-universal condition that has been reasonably shown to be a possibility. Every single one except one postulate, one hypothesis. There's only one that has survived, and that's the universe, the perfect stability universe prior to the Big Bang. So according to the perfect stability universe, and they have many names for it, cosmic, so forth and so on, but basically it's perfect stability universe. Why is this the only possible scenario that's going to avoid the Bordova-Lincoln and Guth proof? Because if it's perfectly stable, right, if it stayed the same for an infinite, it's sometimes called the infinite static universe. If you postulate something that's infinitely static, it's not going to expand. And if it doesn't expand, right, then it's not subject to BVG. So if it was literally static for an infinite amount of time, I can't prove that it has a beginning. There's only one problem with the infinite static universe. Yes, BVG doesn't apply to it. However, it's an intrinsic contradiction, and it violates the laws of quantum mechanics. Now, of course, I'm not going to tell you the quantum mechanical thing because it's a bit too complicated mathematically. However, you could go to magicenter.com and click on Alexander Vilenkin's lecture where he's at the 2012 birthday party of Stephen Hawking that Lisa Grossman, his paper was called Why Physicists Cannot Avoid a Creation. And Lisa Grossman, covering it for the New York Times, called it the worst birthday present ever for Holland. Right? So, but to make a long story short, he shows the quantum mechanical difficulties. But listen to the intrinsic contradiction, and you'll be satisfied. I mean, if something is going to be in an infinitely static condition, ladies and gentlemen, then it's going to have to be perfectly, perfectly stable. You can't have any metastability in it. If you have metastability, that means some instability within the system itself. The instability will cause the universe as a whole to do something internally, right? Something intrinsic, either expand or contract or do something, but it's not going to be perfectly static. So you have perfect stability for an infinite amount of time. And then, that's all conjecture. But we finally got a fact. 13.8 billion years ago, plus or minus 100 million years, there was a big bang. And the universe blew up and expanded. Now, in order for the universe to blow up and expand, it needs what? Instability or metastability within the system. A perfectly stable entity can't blow up. It just stays perfectly stable. What does that mean? You have an instability in the system proven by the Big Bang 13.8 billion years ago, and a conjecture of infinite stability prior to that time. What does that mean? The infinitely static universe means this: a perfectly stable, unstable universe. Which is a what? An obvious contradiction. Exactly. And by the way, quantum mechanics blows it up anyway. So what's the point? There's no escape. And we'll read a quote from Vilenkin in just a few minutes, which basically says the same thing. Right now, there isn't any theory, configuration of physical reality that does not require a beginning. I don't care whether you're talking about a multiverse, whether you're talking about a higher dimensional space universe in string theory, whether you're talking about a perfectly stable universe, which turns out to be an intrinsic contradiction, whether you're talking about just our universe by itself, every single one of those scenarios, and the bouncing universe, of course, which is dead-owed on arrival, right? All of them require a beginning. Even the bouncing universe, which is dead on arrival, requires a beginning, because it must have an average Hubble expansion greater than zero, according to BVG. And there has been no shortage of attempts to try and disprove BVG. But none has come forth so far. And we're talking some really fancy attempts that in the beginning condition, there was a partial domain of de Sitter space in which time went backwards and combined with another part of the de Sitter space in which time was going forward, so that each forward momentum would push a backward dimension, and you look at this and you go, oh, give me a break. You got to go through this kind of conniption to get out of the evidence. Plus, of course, it doesn't work. What's my point? There it stands. Please, I'm just waiting for a response, but none has been given. This is where we stand. We'll talk about a beginning in a moment. I just want to get to another set of evidence very, very rapidly, and that's the whole area of entropy. Einstein once said, by the way, let me just explain entropy for a moment. Entropy is a measurement of what we'll call disorder in physics, right? And chemistry, physical chemistry. Okay, now the idea, disorder is kind of confusing in physics because really what we mean by disorder is equilibrium. What we want in a physical system is disequilibrium. Why is that? Because systems that are in disequilibrium can do work. Systems at perfect equilibrium can't do any work. So a system that can't do any work we call a dead system. And if the universe, described by the Big Bang model, is a physical system, if it's at thermodynamic equilibrium, it's a dead universe. No good. That means there's not going to be any stars in it that are exploding. There's not going to be any exoplanets getting formed. There's not going to be any physicists theorizing about it. No work, dead. For all intents and purposes, then, just think the following. You want disequilibrium in the universe. Now, you can have disequilibrium according to temperature. So over here, you've got a hot burning star, and over here, you've got some cold space. Fine. Disequilibrium. Hot one place, cold in another place, right? Or you have high pressure in this place, low pressure in this place. So the system wants to go to equilibrium to equal out the high and low pressure, right? But the disequilibrium is what causes the work potential. The same thing with atomic distribution, right? So you have a very high density here, low density here, right? So forth and so on. Okay, whenever you got disequilibrium, you got the potential to work. Here's the rub, ladies and gentlemen. The rub is every time a physical system does some work, it loses some of its disequilibrium. A teeny little bit of its order. A teeny little bit of its disequilibrium. And so the universe, like every physical system, is like a wind-up toy. that spring eventually is just going to run out, and the wind-up mechanism is just going to stop because there's no more disequilibrium to make it go. For all intents and purposes, then, what we know is this. Number one, every physical system, and Einstein said, I think that this is the one law of physics that will always last. And the reason that I do is I think it's applicable to any physical system, never going to be able to get out of it, and it's true for purely mathematical, probabilistic, statistical reasons. That's what makes it applicable to conditions beyond our universe, from multiverses to string universes, and people know it. It has a vastly applicable, for probabilistic reasons alone, right? Not because we discovered something like the general theory of relativity that applies in our universe. Now, if that's the case, if it really is true that we need disequilibrium every time a system does work, then it's going to lose a teeny bit of its disequilibrium. Once it loses all of its disequilibrium, it reaches what we call thermodynamic equilibrium. That's maximum entropy, in which case the system, the universe, is dead. You tell me, if the universe has been around for an infinite amount of time, working, stars burning, planets forming, physicists thinking about it, if the universe has been doing this for an infinite amount of time, and you have a finite amount of disequilibrium in any given universe, right? You do have a finite amount of disequilibrium, then what's the universe going to be today? Dead. But we're anything but dead. The inconvenient fact is stars are still burning. Stars are still being formed. Planets are still being formed. And physicists are still thinking about it. For all intents and purposes, energy is being expanded and work is being done. In fact, the entropy rate of our universe is quite low, not high, certainly not at a maximum, which seems to preclude an infinite amount of work in the past, an infinite amount of devolution of disequilibrium in the past, which would indicate or imply a beginning. Now, I have yet to see any consistent theory that shows that entropy is not going to apply to any kind of a physical system, except, of course, a physical system which violates the first law of thermodynamics, a physical system where matter is really being created out of nothing. But if you don't like that, and we'll talk about that in just a moment, it's not a really good theory. If you're not going to get matter being created out of nothing, if you're not going to get a violation of the first law of thermodynamics, matter is neither created nor destroyed, then entropy is going to apply, as Einstein said, to just about any physical condition that we can think of. We can't think of any where it wouldn't. And that gets us to the point of a beginning. Whether you view the universe as whether you view physical reality as having a multiverse, a string universe, a physical universe just like ours, 13.8 billion years old, so long as you don't violate that first law of thermodynamics, it's going to apply. There are some people who have postulated theories that do violate the first law of thermodynamics in multiverse theories, but honestly, far-fetched at best. Far-fetched. So, what's the preponderance of physically realistic evidence suggesting? When you put the entropy evidence together, and you put it together with the Board of Lincoln and Guth proof, right? The universe, the vast applicability of the theorems, the singular conditions, the basis of the theorems on probability or on an airtight theorem, right? When you put that kind of evidence together, you can say that the preponderance of evidence points to a beginning, not just of our universe, but of physical reality. Here's what Alexander Vilenkin proclaimed in 2006. By the way, he's never taken it back. He went to Stephen Hawking's birthday party in 2012, read the paper, right? I mean, no, to all the best physicists in the world sitting there who applauded him, you can just get it on modulcenter.com and look at his presentation. I mean, he's not no holds barred, he's coming right out, and here's what he said. And I'm going to paraphrase it. It is said that a good argument will convince a reasonable person, and that a proof will convince even an unreasonable one. Well, now that the proof is in place, what proof? The Bordova-Lincoln and Guth proof combined with the entropy evidence, which leads to a conclusion that the preponderance of evidence favors a beginning, not just of our universe, but a beginning of multiverses and a beginning of string universes, of physical reality itself. Now that the proof is in place, physicists can no longer hide behind a past eternal universe. There is no escape. They must confront the problem, the reality of a beginning. That's a very strong statement. And the reason he makes the strong statement is because he's got a preponderance of proof upon which to make it. He ain't no fool. He's the director of the Institute of Cosmology at Tufts University there in Boston, and he's got colleagues who are in complete agreement with him. That's where we stand. Now, why is that important for us who may be theistically inclined, or even for those who are not, but at least open to the possibility that there is a God? It is as follows. Just a 3-point argument. Point number 1. When you talk about a beginning of physical reality, you're talking about a beginning of physical space and time itself. So we're talking about the beginning not only of our universe, but if there is a multiverse, a beginning of that. If there is a string universe, a beginning of that. Right? We're talking about a beginning of physical reality, and therefore, physical space and time is intrinsic to physical reality. You're not going to have physical reality without physical space and time. So the beginning of physical reality itself, if science can give evidence for that, it's giving a condition where you're talking about the beginning of physical time. You're talking about the beginning of physical energy. You're talking about the beginning of physical space. You're talking about the beginning of all intelligible constants that control the actions within that physical universe. You're talking about a beginning of everything, prior to which physical reality was nothing. Don't tell me that physical reality tunneled out of nothing all by itself. I'm going to tell you why I don't think that works. And please don't, try and turn nothing into something. Let's face it, nothing is not a quantum system in a false fluctuation that's at a zero energy point. It's still in a quantum system. And the quantum system is something. Thank you. And of course, it's like my bank account. My bank account exists, but most of the time it has a zero balance. Doesn't mean it doesn't exist, that it's nothing. You get the point. For all intents and purposes, what we're dealing with is nothing. And as Parmenides said long ago, please treat nothing as nothing. There's no such thing as nothing, because it's nothing. And the only thing that nothing can do is nothing. It's all it can do, because it's nothing. And it does not exist. There's no such thing as it. Now, if you say physical reality came into existence at this juncture, and we're talking about no prior physical condition, that's what you mean, then I can tell you the following fact. Number 2, the universe could not have moved itself from nothing to something when it was nothing, because the only thing it could do when it was nothing is nothing. And if the universe could not have moved itself from nothing to something when it was nothing, then the final conclusion, something else had to do it. Some other condition, something outside of physical reality, something outside physical space and time, had to move the universe from nothing to something when it was nothing. Stephen Hawking can't make something come out of nothing. He can't do that. Now, he's made a very fancy conjecture in the grand design, which I dispute wholeheartedly, because, of course, he equates nothing with the laws of gravitation. Very cagey. Because now if you say, what preceded physical reality were the laws of gravitation, an intelligible reality that's not yet embedded in physical reality. Right you are. The laws of gravitation could exist prior to physical reality itself. But they don't exist in nothing. What is holding together the equal sign of physics in that physics equation? It's not just an equal sign. The equal sign means something that's holding the left side together with the right side. The laws of gravitation, the equal sign that holds the entire thing together intelligibly, has to be mental, mentative. If there's no mentative reality for physical equations, it simply does not exist in nothing. It can't exist of itself without some mentative reality holding it together in a unity in its disparate parts, all of which are intelligible, requiring a mentative act. So if you say that the laws of gravitation existed prior to physical reality as a whole, then I'd say it'd have to exist in a mentative state, in which case I would call that the mind of God. Thank you for the proof of God, Stephen. I buy it. I totally do. So enough said. But I think what we have here is something else has to be transphysical, transtemporal, transspatial, at least transphysical time, transphysical space. It has to be something beyond the universe as a whole, capable of a huge causative act of creating the universe, or if there is a multiverse, creating the multiverse in a single reality, which of course hangs together in a unitive continuum and is exceedingly complex in all of its fine-tuning in order to make the universe sustain a life form or give birth to a universe that will have a life form. So I think what we're dealing with here is, if you really believe in a beginning of physical reality, and I'm not saying that a discovery couldn't be made 10 years, 20 years from now that might disprove the Borda-Vilenkin and Guth proof or the entropy evidence. But right now, that doesn't look very likely. And that the reason is, as I said, is because there's a single condition which is vastly applicable. You're going to have to find some non-expanding condition which is not intrinsically contradictory, which can get around entropy. Good luck. It will be hard. No shortage of attempts to do it with real fancy stuff. Nothing yet. We may be looking right into the face of God. Enough said. Let's go to one other quality, if I might. Do I still have about 10 minutes to go into the intelligible cosmic stuff? Okay.
You're at 8:05 right now.
8:05? Whew. Okay. All right. What time?
Everybody's saying you're 5.
Okay. All right. Very good. All right. Let me just get into the bottom part of the triangle. Okay. The bottom part of the triangle, what we're going to call anthropic coincidences or fine-tuning. This is a different kind of an argument from argument for a beginning. And what we notice in fine-tuning arguments is just the following. There seems to be some highly, highly, highly improbable fine-tuning that must be present at the Big Bang in order for any life form to develop within the universe. So it's highly improbable. It's absolutely necessary for a life form to develop in the universe. And it just so happens that this highly improbable condition necessary for all life forms was present at the Big Bang. Now, there's two sides to that argument. The first is it implies that there is a great deal of fine-tuning in the universe, which in turn implies an intelligence to make that fine-tuning possible. But as we shall see, there is an alternative called the multiverse that we're going to discuss seriously in a moment, because it does provide at least a naturalistic hypothesis to get out of a fine-tuning or an intelligent designer argument, which I'll talk about. Before I do get into those cosmic coincidences, though, the one thing I really want to emphasize is use arguments which are strong. You know the old saying, right? A chain is only as strong as its weakest link. I myself, Steve Meyer is my good friend. I certainly believe that he has such an insight into biology and biology, manifesting itself, in intelligent design within all of the conditions of evolution, physical evolution as we know it. But you can't prove it. It's just like, man, it seems like it's so. It's really unbelievably improbable that it wouldn't be so. But here's the problem. If you take an intelligent design argument that occurs after the Big Bang, so you're talking about like the Cambrian explosion, right? And that's way after the Big Bang, Cambrian explosion of species, right? And you go, wow, what are the odds that this is going to happen? What is there in our genetic construct that could ever explain this? None. I agree with Stephen. But the problem is, a scientist could always say, we don't know everything about physical chemistry, and we don't know everything about biology. Somebody someday might discover a natural cause of this phenomenon that we do not yet know. And then you kind of get into the embarrassing situation of sort of over, claiming. So the best thing is use arguments that begin with the Big Bang. Why is that? Because the Big Bang is causally disconnected from everything that came before it. Repeat. The Big Bang is disconnected causally from everything that came before. So if there was a pre-universal condition, when it goes through the singularity to go to the Big Bang explosion, all the causal connections are gone. You've got to start over. Even if there was an oscillating universe, and now we know that it probably that if you had a collapse, it would turn into a black universe anyway at maximum entropy, right? For all intents and purposes, it'd still be causally disconnected from any previous bounce, etc. So that's great. Why is that? Because now you can't say there's a mysterious natural cause that could have occurred prior to the Big Bang, which will explain the fine-tuning at the Big Bang. So use arguments where the fine-tuning is at the Big Bang. That way you don't fall prey to, there's the unknown natural cause that we don't know about, which is a perfectly legitimate objection. Two Big Bang arguments really quickly. One based on low entropy, and the other one based on universal constants. Excuse me, being brain dead here. So the main thing is, when you're dealing with low entropy, remember low entropy is high order. Now I'm not going to explain all this to you, but high order is really, 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 really improbable. So in order to have a real low entropy universe at the Big Bang, and we have a very low entropy universe at the Big Bang, right, you're going to have an immense amount of fine-tuning, which is highly improbable. Now, what are the exact figures for this? Oh, by the way, we need every bit of that low entropy at the Big Bang in order to have life forms arise within the universe, to develop and evolve within the universe. You need low entropy. If you got high entropy, you're dead on arrival. That universe is not going to work for the natural development of a life form out of physical systems. It just won't be enough time or enough energy in order to work within the physical system to do it. Okay, so what are the odds that we're going to have the low entropy we have in the universe by pure chance, according to Roger Penrose? 10 raised to the 10 raised to the 123 to 1 against. This is a double exponent, ladies and gentlemen. This is a big number. It's like a 10, and if you reduced it to a single exponent, it'd be a 1 followed by 123 zeros. In the exponent is a trillion, 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 trillion. In the exponent. So if you wrote that number out with every zero being 10-point type, our solar system out to the extreme edges of the solar system would not hold that number. It's the same odds as a monkey typing the entire corpus of Shakespeare by random tapping of the keys in a single try. You walk into the room after the monkey has been tapping on the typewriter. He's been at it, lo and behold, for several weeks. And you look at the desk, and there's Macbeth in perfect folio condition. And you go, wow. And then you look, and the next one underneath is Hamlet in perfect folio condition. And you begin to think, wow, this is highly improbable. And indeed it is. It's the same improbability of our universe having low entropy by pure chance at the Big Bang. Now, there's only two. If anybody tells you this can happen in a single try, you just go, I got a bridge to sell you. Because, of course, this person will believe anything. This is not going to happen. And that means the person's going to literally believe that the monkey can type Shakespeare in one try perfectly with random tapping of the keys. You know, I mean, a monkey can't even type 3 words together of Shakespeare, you know, with an infinite amount of time practically, not the corpus. So what's the only two things you can make recourse to? Either God put all that fine-tuning in the universe and enabled all that low entropy to exist, right? So that a high entropy universe would not come out that would be impossible for life to develop in. Or you've got a multiverse, and remember, a multiverse is possible. It's hypothetical, but it's possible. But it's always going to require a beginning, so you can't have an infinite number of bubble universes, because the bubble universes have to be, come out over the course of time. They can't come out all at once. So for all intents and purposes, you're going to have a limited number, but you really could theoretically have 10 raised to the 10 raised to the 123 bubble universes, and all you have to do is postulate a near infinity of bubble universes, just to explain one, ours. Now, some people say, well, that's a violation of Occam's razor, right? That's a violation of the what's called the canon of parsimony. That's a violation, right? As Paul Davies calls it. Well, it's like bringing excess baggage to cosmic extremes, and it is, but it's nevertheless possible, right? So whether it violates Occam's razor or not, yes, nature and the universe favor elegance, ever and always. It favors elegance, but maybe in this case it doesn't. So that's not going to disprove it. Yes, all multiverses require a beginning, but maybe it lasted for 10 to the 123 years. It's a lot of years, but maybe it did, and it burped out all those universes, and one of them finally came out, namely our own. Possible, but the real kicker is this. Every single known multiverse hypothesis requires fine-tuning in its initial constants and conditions in order for it to burp out universes that are not self-destructive. For example, Andre Linde has a chaotic fractal multiverse, right? But that chaotic fractal multiverse can't just arbitrarily burp out bubble universes from within itself. It's actually going to have to do this very systematically. There's going to have to be a slow roll of bubble universes. Why does there have to be a slow roll of bubble universes? Which, by the way, requires a whole lot of fine-tuning in the initial conditions of the multiverse, because if those bubble universes, if their gravitational attraction in the multiverse, right, universes have a lot more gravitational attraction than mere galaxies, right? I mean, if you got these bubble universes coming within close proximity to one another, the gravitational perturbations would be so violent it would just shake the entire bubble universe like a jello, which would be exceedingly bad for the development of life forms. So for all intents and purposes, you got to, and if they collide, holy mackerel! I mean, 2 galaxies colliding is bad enough. 2 universes? Lord. So you get the point. Excuse me, Lord. But this would not be good for life forms. Well, what does that mean? The multiverse hypothesis, if it doesn't have fine-tuning, it doesn't get out bubble universes capable of sustaining life. And that means that the multiverse hypothesis only moves the problem back one step. It does not solve the problem. The problem, still, you're going to have to explain the fine-tuning of the multiverse, which has no apparent physical explanation, which implies a cause outside of that physical reality. An intelligent cause of the fine-tuning of the multiverse outside of that physical reality. I'll talk about Dawkins for a few minutes just at the end of the talk here, but I just want to get to a couple other fine-tuning arguments so you can see, there's not just the low entropy argument. There's also, we've got 20 constants in our universe. And these 20 constants have a very specific value. And it's very important that they have the exact values that they have. Because if they have a value ever so slightly higher or ever so slightly lower, then of course, the universe in question would not be able to expand any life form whatsoever. These constants must have those exact values at the Big Bang, or you're not going to get any life forms in the universe whatsoever. Just 3 quick examples and you can get it. I just talked about the 4 forces in the universe. They have all these constants associated with them, right? So these constants that have these specific mathematical values. For example, you have the strong nuclear force has the strong nuclear force coupling constant. The gravitational force has the gravitational constant. The weak force has the weak force constant. And the electromagnetic force has 3 constants associated with it, right? It's got the electromagnetic charge, it's got the mass of the proton and the mass of the electron. And furthermore, right, there are other constants. You probably have heard of Hubble's constant. You've probably heard of the cosmological constant. You've probably heard of Planck's constant. Okay, there's 20 of these guys. All right, now here's the rub. If you just elevate the value of the gravitational constant or the weak force constant, just those 2 constants, if you elevated it or lowered it by 1 part in 10 to the 50th, that's a really small fraction. That's a decimal point followed by 49 zeros and a 1. If you just took 1 part in 10 to the 50th of the values of those constants, raised them either higher or lower by that little teeny fraction, then either the universe would have been continuously exploding in its expansion, which parenthetically is very bad for life forms since everything just burns up, or the universe collapses into a gigantic black hole, in which case the entire mass energy of the universe is collapsed into 10 to the minus 33 centimeters with almost infinite crushing power, which is also exceedingly bad for all life forms. For all intents and purposes, you mean we averted complete cosmological disaster by 1 part in 10 to the 50th and just those 2 constants? Yep. You know the odds against these 2 constants being precisely what they are within a window of 1 part in 10 to the 50th? Monkeys typing Shakespeare, or at least monkeys typing Macbeth. Here, just 2 more and you'll get the point. A third one. If you take the strong nuclear force coupling constant and you elevate that constant by just 2% higher than the value it just happened to have at the Big Bang, then there's going to be absolutely no hydrogen in our universe. That's bad. No hydrogen, no stars. No stars, no heat. No hydrogen, no water. Bad for life forms. Alternatively, if you just lowered it by 2%, the strong nuclear force coupling constant, by 2%, you would have no element heavier than hydrogen. No helium, no carbon, no iron. Go ahead, I defy anybody. Come up with a model of making a complex life form with only hydrogen atoms. Go ahead. You're not going to do it because you can't do it because they don't have the intrinsic possibilities of making complex combinations without fusion. I mean, we just lucked out. You know the odds of Right? Do you mean we just averted cosmological disaster by 2% at the Big Bang, the strong nuclear force? Yeah. You know the odds of this? Oh, you know, a monkey typing maybe the first 5 pages of Macbeth flawlessly. How about one last one just for the kicker? If you altered the gravitational force constant or the mass of the proton, the mass of the electron, or the electromagnetic charge by 1 part in 10 to the 39th, higher or lower than the values they just happen to have at the Big Bang, then every star in our universe would be a blue giant or a red dwarf. If every star were a blue giant, these stars are huge. They're constantly burning. They burn things for light years beyond them. They incinerate everything. Exceedingly bad for life form. If every single star is a blue giant, forget it. Everything's fried. Alternatively, if every star in our universe is a red dwarf, then everything's going to freeze, ladies and gentlemen, because there's not even going to be enough heat to tan a Hawaiian. There's going to be nothing. For all intents and purposes, everything fries or everything freezes on the basis of 4 constants, just happening to get the exact values that they need to get at the Big Bang by pure chance. The odds are against it. Monkeys typing Shakespeare. I mean, now we've got, with the low entropy of the universe, the constants of the universe, we got monkeys not only typing Shakespeare, we got monkeys typing the entire corpus of English literature by pure random tapping of the keys in a single try. If there's not design, and there's going to have to be a lot of bubble universes in a multiverse. And even if there is a lot of them, like 10 raised to the 10 raised to the 10 raised to the 10 raised to the 123 to 1, even if you had that many, that universe would still not be able to, that multiverse, would not be able to explain its own fine-tuning, moving the entire process back 1 step. I'll leave you with 2 quotes, and then we can get into Dawkins in the Q&A if you want to. First quote comes from Fred Hoyle. And again, I got to paraphrase it, but it goes something like this. You know, Fred said, by the way, he used to be the gadfly of atheism, right, in physics for like 30 years. And one day his partner comes in and says to him, Fred, I've been looking at the odds against having an abundance of carbon atoms in the universe by pure chance because of the resonance levels of carbon, of beryllium, hydrogen, and helium. And Fred goes, let me see that, and takes a look at the calculations, and he finally gave up. And he said, I don't think that there are any blind forces worth speaking about in the universe. It seems to me that some super calculating, super intellect has monkeyed with the constants of physics and those of chemistry and biology as well. I consider this conclusion to be beyond the shadow of a doubt. Multiverses in their inadequacy notwithstanding. I think the evidence is leading us today not only to a reality of not only to the beginning of physical reality, not only to the implications of a creator from that, but I think also to the implications that creator outside of space-time asymmetry, even outside of physical reality configured as a universe, has to be highly, highly, highly intelligent. And so I leave you with these words of Robert Jastrow, who wrote a book a long time ago, it's called God and the Astronomers. He was NASA's, the founding director of NASA's Goddard Institute of Space Studies. And this is how he put it, again, it's a paraphrase. Scientists unshackled themselves from the domain of superstition, taking on a strict methodology of empirical research, mathematical measurement, and the science, the queen of mathematics herself, began to ascend the heights of knowledge, came to its final precipice, pulled themselves over, and found a band of theologians there, awaiting them for centuries. Thank you very, very much. Thank you very much. So, thank you very much.
We should probably let people go. Put it off without the Q&A. It's pretty late.
Thank you. Well, I thank you very much. I know we're a little short on time. I do want to do the Q&A. If you do have questions about BVG proof or about Dawkins or anything, you know, I mean, it could be theology, whatever. I would love to entertain them. I'm going to have somebody actually recognize the questioners. I've got RP.
Can I go first?
Yeah.
Thank you, Father. I didn't understand a lot of what you said. But what I did understand...
Where could you get it, though, if you wanted to review
I probably
it?
could if I tried.
You
probably
could go
could.
to magicenter.com.
But my question is, a lot of the men here study philosophy,
Yeah.
and a classic debate in the Middle Ages was, is it possible to prove creation ex nihilo philosophically? St. Thomas thought no. Do you think the new physical evidence from science changes that?
Yes, I do.
Are we in a different space than St. Thomas, even
Yeah.
philosophically?
Yeah, we are in a different space. And I wrote a book called New Proofs for the Existence of God, and in that I do a reconsideration of the physical proof. Again, remember, scientific proof is not like a metaphysical proof, right? A metaphysical proof will, if you deny the conclusion of a metaphysical proof that's done properly, that will either show you that nothing exists, clearly contrary to fact, or a clear intrinsic contradiction. Scientific evidence doesn't work that way, but what you do have are highly probabilistic grounds. So you can't get, even the Borda-Vilenkin and Guth proof, even though it's called a proof, right? You know, there might be some discovery where you could get out of, you know, some, expansionary condition or a perfectly static condition. But with that caveat in mind, yes, things have definitely changed. And they've changed in 4 respects. One of the people who changed things was Father Georges Lemaitre. The idea of a universe as a whole interrelated physical system did not exist at the time of St. Thomas Aquinas, who assumed the Aristotelian viewpoint about time and space. Secondly, we now know that physical time, is not just a measurement of motion. Physical time has real effects. And we see these real effects in 3 theories, in what's called quantum theory, also in general relativity theory, and in special relativity theory. Time is not just a measure of motion, which could be viewed as some kind of intrinsic quantifiability within a changeable entity, right? What we're dealing with is a reality that actually has effects. Now, interestingly enough, there was a doctor of the church who did have a conception of time like that, and that was St. Augustine in the Confessions, does have a notion of physical time that more resembles what I would call general relativity. The person who bridged the connection very effectively between philosophy and general theory of relativity is a French philosopher named Henri Bergson in a very important and good book, still very valid today, called Duration and Simultaneity. He did not know about quantum time, but he does have a very good angle on the Thomistic philosophy as well as the Science of General Relativity, which is an important book. I use him myself in New Proofs. The third thing that is really important is you didn't have a set of known physical laws within a physical system that could be determinant of what's called a space-time curvature or a necessary beginning. Like in the Borda-Vilenkin and Guth proof, you have to have a beginning, otherwise you're going to violate the need for a maximum velocity in the universe. It doesn't matter what the maximum velocity is, right? Whether it's the speed of light or not is irrelevant. What is relevant is you do need a maximum velocity, and that's why the Borda-Vilenkin and Guth proof really has a solid foundation. Because if you don't have a maximum velocity in your universe, a finite maximum velocity, then everything's zinging around at an infinite velocity. That's bad, because that means that you're multiplying matter at all times. So the photon is every space-time point in the universe simultaneously. Nay, every photon, every electron, every proton is everywhere simultaneously. What's the matter with that? A universe filled with contradictions. Yiko. So if you do admit that you do need a maximum velocity, then you are going to have to admit to Bordelenkinen-Guth and other kinds of singularity theorems where you get to what's called infinite curvature of space and time, where everything goes to a point. Now, did Thomas know any of this? No, he didn't. Did Aristotle? No. But the experimental evidence wasn't there. Am I convinced that Thomas would have changed his mind? He would have done so with this caveat, in my opinion. No, we can't know with metaphysical certainty that the universe, from scientific evidence, has a beginning. But we can know with qualified probabilistic certainty that it likely had a beginning if all of these sets of evidence from entropy and from Bordelenkinen-Guth and other space-time geometry proofs, if they all converge on the same conclusions, requirement for a beginning of multiverses, universes. Yeah, it's a whole different world out there. Physics is really different. And the person who blew it all up initially was a priest himself, Father Georges Lemaitre. I mean, it is the Big Bang as the solution to the equations that starts the tilt in a whole new direction of viewing physical reality.
If I understand that, the answer is yes.
Good.
So, Father, for the sake of time, we have time for 2 more questions, and then we have the reception where you'll be able to greet people afterwards as well.
And I'm happy to talk about it in a reception as well. Other questions?
Father, we're being besieged by activist atheists. You've mentioned a few.
Yeah.
Sam Harris, of course,
Yeah.
Richard Dawkins.
Yeah.
But there's one you didn't mention, Lawrence Krauss.
Yeah.
At the University of Arizona, and I believe he's the one who wrote the book Something from Nothing.
Yeah.
And I think his argument was the gravitational waves. Now, I'm a little bit confused. Maybe you could shed some light, because he's very vocal. He's drawn a line in the sand that basically religion should be eliminated.
Yeah. Lawrence Krauss is a very angry person. By the way, I was at Arizona. Yes. That was an ad hominem argument, but it's true. But the long and the short of it is, I did it. I was at ASU, for 2 full 2.5-hour sessions each. I invited him both times to my sessions. He did not come, so I don't know why. I mean, maybe he didn't get the invitation, but it was sent out multiple times. But I can just tell you this: anyone who makes recourse to gravitational wave, or not gravitational waves. Because there can't be any gravitational waves without a universe in which to inhere, right? Gravitational wave is a derivative of general theory of relativity, where space-time is giving rise to gravity through the curvature of the space-time continuum. So you're not going to have a gravitational wave without a general relativistic configuration in the universe. But if you're talking, you see, Stephen Hawking is much slyer. He says gravitational laws. Now, if you get back, you see, gravitational waves, no way. If you have a true beginning, and Krauss has never. Where do you find Bordelenkinen-Guth successfully refuted by Lawrence Krauss? You don't. Where do you find entropy successfully refuted by Lawrence Krauss? You don't. Now, Sean Carroll tries to get out of entropy with an ingenious multiverse theory, but I believe it violates the first principle of thermodynamics. That being the case, staying on Krauss for just a moment, I think you've got to, just simply continue to present the evidence, continue to respond with rejoinders that you have not successfully refuted the evidence in favor, and you certainly by science cannot disprove God. You cannot even disprove, you cannot even prove that the universe does not need a creator from the complete explicability of physical reasoning for the reasons I mentioned. So I think the Kraussian arguments are weak by nature. So that's the first thing. I mean, right? There are far more errors of omission than commission, right? So if you leave out all the good arguments of your opponents, that's not a healthy sign that you have a credible argument. The second thing, of course, is that, as I said before, Krauss does have a thing about religion. It's not just God. He is very convinced that, religion is a terrible and bad thing. One quick thing on that matter, it's out of the domain of physics, because, religion has been a whipping boy of the popular press. And I have to tell you right now, no one can possibly advocate that religion has done more harm than good in the history of humankind. This is just a complete revisionist view of history. And why so? Because, first of all, where do you think every legal code came from that civilized us? From religious codes. There's no legal code that did not spring from a religious one. Where did the religious code spring from? The awareness of the sacred and the conscience that is within us, absolutely, that has these two interior awarenesses that congealed around, yes, revealed religions, but that those religions gave rise to legal codes. Number two, who in the world ever spoke out in favor of people who were the poor, the downtrodden, right, the widows, the orphans? It was religious people. It was the prophets. These were the ones that threatened, God, with the vengeance of God on those who wouldn't take care of, people who were helpless, right? I mean, it was they who actually, took the time to take care of the widows and orphans, right? And then you get to Christianity, where the most extraordinary things happened. I mean, Rome, do you really believe the intellectuals can give rise to a compassionate society? Peter Singer at Princeton, right? Infanticide should be allowed. Don't want any inferiors getting out there. You're going to trust the compassionate society, the compassionate culture to the intellectuals? I dare say not. We will be overcome by the collective ego I'm an academic myself, but there's a lot of ego in academics, and it really gets in the way of compassion. My thought is, just look at Christianity and look at what it did. Number one, Jesus' dictum, right, of the golden rule instead of the silver rule. Silver rule is present in every culture, right? Do not do unto others what you would not have them do unto you. Don't do a harm to others you don't want done to you. Avoid, unnecessary harms. And if a harm is unavoidable, then minimize it. Now, that's a silver rule. Everybody's got it. Buddhists have it. Every form of theism practically has it. Old Testament has it on multiple occasions, etc. But the golden rule, that's a whole different deal. That's not ethical minimalism. That's not avoiding unnecessary harms. The golden rule says, very cagily took the knot out of that, right? Do unto others as you would have them do unto you. Do the good for others that you want done unto you. The altruistic society is born out of his love. And I'm telling you, the golden rule changed everything. Changed everything for Rome. Look at what happens. Jesus identifies himself with the least of his brothers and sisters. The minute he does that, notice what happens. The Christian church immediately says, well, we better serve the slaves. We better serve people beyond the Christian community. We've got to get out there and make a difference. So what did they do? They started a public welfare system. Guess what, everybody? What's the largest public welfare system internationally today? Yeah, Catholic Church, thank you. Number two, they went out and they started a public health system. And what is the number one international public health system by far today? Catholic Church. Number three, they started educating people. What's the number one public education system, bar none, internationally today? The Catholic Church. And of course, that's why the Catholic Church was responsible for science and everything else. But what were they doing with all this? The golden rule. They were undermining slavery. Yes, it kind of, merged into serfdom ultimately, but it wasn't Roman slavery. And the cruelties of 4 million people dying in the Colosseum, there's your stoic society without God and the compassion of, religious thought. That, I got carried away, but I mean, my main point is I think these kinds of, very ham-handed is what they are, arguments for revisionist history that, because of the Crusades, religion did more harm than good. Oh, read a page of history, I mean, honestly, I truly have to say, they're very ham-handed arguments, and I really, when people get into these and they get away from physics, it's not, we just have to respond to them and move on. You can't, hate your enemy. You have to pray for them. But I think at the same time, yeah, I don't think these are credible arguments. I think they're fraught with omissions, as Dawkins' argument is. I get into that with you, but I better wait for the last question. And so thank you for a very good thing that got me way too far going.
Father, as a victim of 11 years of Jesuit education, it is always refreshing to have my intellectual inferiority reminded. But I really never got off square one, and that was the reason you were here, or at least made this address, is that you're alarmed at the accelerated rate of the kids losing the faith or belief in God, at least. Mm-hmm. And how do you account for that, and what can be done to counteract it if possible?
Well, I would say our competition has got a 20-year head start on us, and they're very slick. And unfortunately, the media have chosen to make them their darlings instead of us. Just on my advisory board alone, I've got lots and lots of tremendous physicists. If you go to our website, magicenter.com, you have 10, Nobel Prize-winning, Templeton Prize-winning physicists talking about their faith from the vantage point of science, called Cosmic Origins. Just click on it. It's free of charge. Download it. Show it to your students. But what's my point? My point is, we got to get the word out there. And by the way, I didn't pay him to ask me this question, because this is really, my point. All of us are in this for the long haul. I was telling the faculty today, I was signing books at the Los Angeles Religious Education Congress right next to Bishop Robert Barron day before yesterday. And, I was listening to him say something to a guy next to me. And the guy had said, well, why are we getting so excited about, the science and religion and atheism and so forth and so on. I mean, look, we got 60,000 people here at this Congress. And Bishop Barron said something like, well, look, if I was running a big corporation and I was losing 6 members for every one I was gaining, I'd call a meeting because everybody's got to get on board to stop this critical attrition for no good reason from the Christian church. And I'm going to just leave it at that. I'm begging you to look at our website, magicenter.com. There's a very fine Protestant guy as well, William Lane Craig, and his a very fine physicist friend, Jim Sinclair. There are other really great websites. You need more than 1 million likes on your Facebook. You need more than 8 million clicks every couple of months on your website. You need 50 million if you're going to make the cultural change with the youth. But it's working. I'm telling you, even with our little website, trying to, creep out 1 million, folks for the Facebook, or 8 million clicks for every 2 months, we know it's having great effects. People come up to us all the time. We're getting all kinds of good feedback, but we really have to grow. And the other area we got to grow, we're trying to do this compendium that, Father Chris Martin was talking about, in the introduction. We want to get it in every high school, every Catholic center at a university, all the confirmation programs in the RCIA. We have to get science and theology together. I mean, with confirmation, you got one shot at these kids. They're probably going to go to a public university, and they're probably never going to take a religion course again after they get confirmed. You got to get them. You got to get the evidence out. You got to get it in a fast curriculum. So we are trying to put that together, but what we need is publicity galore. Sister Marianne Postiglione is here from iTest, and she was saying that they're looking for a grant to try and bring these things into various high schools, and I think that is going to be terrific. But the trick is everybody needs to be on board, as Bishop Barron would say. We got to call a meeting, and even if we're not science types, even if we're just the types that, can say, go to this website, magicenter.com. There's this crazy Jesuit Spitzer. You can listen to him or to these other physicists talking about, the evidence for God from physics. But whatever you do, don't leave for scientific reasons, because there isn't a scientific reason. That's what we really want to get out. If you videotape this tonight, spread the word. We're happy to, we'll take the thing and send it to a huge email list. But everybody's got to get on board, and we got to think of a strategy. I am meeting with the bishops in September and November to tell them all about this database we're forming, the various materials we have, so that we can get a nod from them to start making that holistic approach to getting the word out. That, as I would say, the evidence favors us. Evidence doesn't favor them. We're the cooler heads. The anger, that's displayed clearly by Harris and Krauss and Dawkins is just amazing to me. What did religion ever do to you? Maybe it did something to them. I don't know. Maybe they were raised in a difficult household. But the evidence favors us. You don't have to be unreasonable or irresponsible to have faith in the 21st century. It's overwhelming. I didn't even talk about the evidence from peer-reviewed medical journals of near-death experiences for a transphysical soul that exists after physical. I mean, the evidence is overwhelming. Just go to our magicenter.com, read the article, honestly, called Science, Medicine, and Near-Death Experiences, and the one on the Shroud of Turin. I mean, God left us another great relic of a dead body that emanated literally several billion watts of energy for 1/40 billionth of a second to produce the most unique image on the surface of the fibrils of this shroud in history. Why don't our kids know about this? Because it's not in mainstream media. Yes, National Geographic. National Geographic, what's the readership? Older. EWTN, I got a show, Father Spitzer's Universe, talk about this stuff. What's the demographic? 55 and older. I mean, we got to get into social media. We got to get into the schools. Your question is fantastic. The evidence is there. What we need is creativity, zip, and a whole lot of, social media drive, and we can do it. We can turn this around, and we can even reconvert the ones who are erroneously converted to the opposition point of view. But it's great.
Father Spitzer, thank you. I feel like the other guy in the movie Good Will Hunting that's just standing next to the genius, be like, how do you like me now? So your intellect is unparalleled and your enthusiasm is contagious. So thank you for spending your time with us. Thank you for the good work that you do for the church. And we thank you also for being willing that right up the staircase here, we'll have a brief reception. And Father Spitzer said he's willing to meet and greet. And so we thank all of you for attending this evening as well. So thank you.